All right, so I wanted to start here because PERT is where a lot of our problems started. So I'm going to take you through PERT as well as the critical path method in this video. So it's going to be a short video just taking you through that part only. I will do the work breakdown structure as well as another instructional on the Gantt chart, but I wanted to start here because this is the next pressing issues that the next pressing topic that we have to look at after we return from our test on Tuesday, right? So this is where we are. The first things I want to do though is I want to take the time to define these terms. So if you can, or rather you should screenshot this part here so that you can remember these terminologies in case you aren't able to go into the textbook to find it. So when it comes to our early start, we are looking to find the earliest time that an activity can start once the previous dependent activities are completed, right? So once you have no predecessors or you have no activities in front of this one, so basically your first activity, it always starts with 0. The next one that we have is your earliest finish, and your earliest finish is simply going to be the earliest start plus the duration of the current activity. Our latest finish is the one that we calculate third before a late start. We calculate it this way because we need to find the latest time an activity can finish without delaying the project. And we usually start calculating our late finish from the last activity. So we go all the way through using our forward pass method to find our early start and early finish. And then once we get to the final activity, we go backward using our backward pass to find the late finish and then the late start. So your late finish is going to start from the last activity. That's going to be the latest time that you can finish that activity without delaying your project. Then we have our late start, which is going to be the latest time an activity can start without delaying the project. Then we have our free float, which is the amount of time an activity can be delayed without affecting the early start of activities coming up or subsequent activities. And then our final float is, our total float is going to be the total amount of time that any activity can be delayed without affecting the overall project completion. So free float deals with delaying one activity or subsequent activities that we can still make up for if there's some slack in there. But total float means that when you delay something here, you delay the project completion date, right? Now, when it comes to calculating these terms, this is how we find them, right? So we use a forward pass method, and we use that one to determine our early start and early finish. Then we do our backward pass, and that helps us to find our late finish first, and then our late start, right? So we find the late finish, and then, well, we find the late start by subtracting duration. So the next one is our early start, and our formula for that is the maximum early finish of all predecessing activities. Predecessor activities. Our early finish is our early start plus the duration. Just to note here again, when it comes to your early start, if there are no activities in front of it, no predecessing, what is the word there? And no activities coming in front. So once we're starting at the first activity again, we always start with 0, right? Early finish, that's your early start plus duration. Our late finish is going to be the minimum of our late start of all successor activities. So I will show you how to find that one. And then we have our late start, which is the late finish minus duration. Once we finish calculating those, we are then going to find our total float, which is going to be the late start minus early start, or it's going to be late finish minus early finish. Then our free float is going to be the early start of succeeding activities minus the early finish of the current activity, right? So the last time we left off, we would have actually calculated this already. So we had already calculated the activity, preceding activities that was given, these two, as well as our time, the duration, these were all given. And I showed you how to just freestyle and scribble our network diagram, right? So now that we freestyled and scribbled that diagram, I actually transposed it into this structure so that we can use this to actually calculate our early start, early finish, etc. So as we were going through stuff just now, I did say that we have to calculate these, right? So let's go ahead and let's start here. So when it comes to our early start, we know that our early start for activity A is going to be 0 because there's no activity happening in front of activity A, right? So we were correct here when we did select 0. Then for activity B, it was also going to be 0 because there's nothing in front of that. Then for activity C, we put 0 also because there are no activities in front there. So let me just go ahead and I will fill this in as we work here. So I will also release this schedule. Yeah, I'll also release this activity here so that we can look at this as an example. Like I will upload this after I've calculated it so that you can see. And it will also have just like this where you have two. So one is going to be filled with the answer and one is going to be blank. Yeah, so we're going to put 0 here. We're going to put 0 here. And we're also going to start 0 here because again, we are filling in our early start for these 3 activities. There's nothing in front, so we know that this is where it starts, right? Now, our early finish for these activities are simply going to be, going by our calculations, is going to be our early start plus our duration. So in this case, it's going to be 7 for activity A because activity A's duration is 7. So 0 plus 7 equals 7, right? For activity B, 0 plus 8 is 8. Activity C, 0 plus 6 is 6, right? Let's go ahead and we will fill those in also. So early finish is going to be 7 here. It's going to be 8, and then we're gonna have 6 for this final one, right? So we've completed our early finish and our early start and early finish for A, B, and C. Now let's look at D. Now D precedes A. Well, D succeeds A, sorry. So we have to look at the early finish for this one, right? So we have 7 as the early finish. So 7 plus 6, which is the duration of this activity. That's going to give you your that's going to give you your early finish, but I actually skipped the early start. The early start for this one is simply going to be 7, right? So we have 7 here for our early start for D. Right, let me put it in right away. And then our early finish for this one is going to end up being 7 plus 6. 7 plus 6, that's going to be 13. For the next one, well, let me just 7 and then 13. For activity E, right? Activity E, we have 8, right, just before. So we know that the early start for activity E is going to be 8. The early start for activity F is also going to be 8. So 8 and 8. Our early finish for activity E is going to be 8 plus 6, which is 14. And then our early finish for activity F is going to be 8 plus 8, which is 16. We look at C and we see that C's early start is going to be day 6 because we finished this one in 6 days. And then our early finish is going to be 6 plus 4, which gives us 10. So 10 days. Again, we're going to come here and we're going to fill these in. So I skipped. I've got 14. I've got 16. Then we have 10 and 6. Right? Now for our final 2 activities, we see activity H, and activity H has 2 activities feeding into it. We've got D and E going here. Now, which one should we choose? D finishes in 13 days, E finishes in 14 days. H needs both of these, which means that they both have to be completed. And so since this one takes longer than D, we have to assume that we can only start H when both are completed. So that means our early start for H is going to be 14. Why is it red? I'm not sure why it's red. Let me just go ahead and change. Yeah, so therefore, our early finish is going to be 14 plus 7, which is going to be 21. right? So I'm going to fill this in here, 14 and then 21. And then for activity I, we have 3 activities feeding into this one. We have activity H, F, and G feeding into activity I, which is our final activity. So which one has the higher amount of completion days? It's going to be 8, so 21. So activity I cannot start until the earliest day 21 because we have to assume that H, F, and G are complete before we can start activity I. Right. So 21 plus 3 is going to give me 24. So therefore my early finish for activity I, and therefore my early finish for my entire project is going to be 24 days, right? So let me go ahead and fill this in also. So we've got 21 and 24. Now, I would have told you that when we're calculating float or slack, anywhere along our critical path, right? So from our first activity to our last activity, right? Most times the first. Well, in this case, we have 3 activities starting off on its own. So who knows what the float looks like here. But our last activity for sure must be along our critical path because you can't finish the project without completing the final activity. So because of that, we know that the variance between our early start and late start and the variance between our early finish and late finish is going to be 0. So, well, are going to be 0. So therefore, our early finish, or sorry, our late finish is going to be 21 and our late start is also going to be, our late finish is going to be 24 and our late start is going to be 21 because the slack, right? The slack or free float, slack or float, sorry, it's just going to be 0, right? So this is just how it looks. Let me go ahead and fill these in. So late start is going to be 21, late finish is going to be 24, and then our total float here, our total float here is just going to be 0, right? That is our final activity. So what we did just now where we went all the way forward is called our forward pass. To calculate our early start and early finish. And what we're doing now is called our backward pass, where we're going from the last activity back to the front, right? So we know that we have no slack on the last activity. So we're here and now we've got to work backwards. So from I, we've got to work back to G, F, and H. So let's look at it. What did we learn about late finish? I told you that late finish is going to be equal to the duration subtracted by the total our duration subtracted by our late finish, right? So we've got 3, we've got 24, it's going to be 21. For this one, we've got 21, which is our late finish. Now we have to find the late start. So it's going to be the late finish subtracted by the duration. So 21 subtracted by 7 is going to give us 14. We do notice that that means that we have no float here, which means that we most likely are still along our critical path. So let's go ahead and fill those in. We've got 21 and we've got 14. Now we finished H. Let's look at F and G, right? So we're starting with 21 here also, right? So our late finish for G is also going to be 21 because that's the latest that we can finish activity G without it affecting I. F again is also going to be 21 because we cannot finish activity F later than day 21 without affecting activity I. Right? So then we look at we go back to G and we look at our duration. We subtract that from our late finish and we get 17. So we understand that we do have some float here. So we have 11 days of float here. Let's go ahead and fill that in. So 11, our late finish was 17. No, that's our late start. Our late finish was 21 and our late start was 17. For activity F, we haven't calculated our late start yet, but our late finish is 21. So 21 subtracted by 8 days, which was our duration, we're going to have 13. 8 from 13 is going to be 5. So our late start is going to end up being 13 here, and then our float for the activity is 5. So we have 5 days that we can play around here. Well, 5 days that we can be delayed here without affecting the entire project. Let's go back up to activity H. So we see D and E feeding from that. So these will both, so our late start here is going to be our late finish for this activity. So 14 and 14 here also, right? So 14 and 14. Then 14 subtracted by 6 days is going to give us 8. So the late start for D is 8, and the late start for E is going to be 10. No, it's going to be 8 also. Hold on. 14 by 6, yeah, 7 plus 1. Cool. So it's going to be 8 here also. Then we notice that this one is 0, so we are along the critical path there. This one has 1 day as float. That's great. Now let's work back C. So activity G is the succeeding activity of C. C therefore has to be completed, right? The late finish can't be anywhere later than 17 days or day 17. So that means 6 from 17 gives us 11. And so our float here is going to be 11 days. Like we can start activity C on day 11 without affecting anything because because activity C just feeds into G, which takes 4 days, and then we should still be able to complete this on time. That absolutely does not mean that you should start activity C on day 11. It just means that you can keep whatever resources you need for activity C. You can keep it for 11 days and distribute it among the other activities without affecting this one, right? So the reason that we calculate the critical path is so that we can make sure that we focus as many resources as needed along that path. So where is the path? Let's continue. Activity B, we see that it has 2 activities succeeding it. It has E as well as F. So what we need to do here is we're going to look for the one that has the lowest amount of days, right? Why lowest and instead of highest? Because it means that this one cannot finish beyond day 8 or else it's going to affect activity E. If it finishes on day 10, it's not going to affect activity F at all because activity F can start up to day 13. However, activity E will be late, right? And then we know that activity E has to feed into activity H, and then that goes straight to I. So because of that, we recognize that we have to use the lower number of the two. So the late finish for this one has to be the late start for the succeeding activity, and therefore it has to be 8. So 8 from 8 gives me 0. So I really should not be messing up here because I recognize right away that this is my critical path, 0, 0, 0, and then 0. Activity A, let's look at that. We see 8, so great, 7, and so we've just got 1. Let me go back and fill these in because we neglected it for a bit there. So activity A, the late finish is 8, B, it's 8 also, and then C, it's actually 17. The late start, however, for this one is 11. The late start for this one, this was activity D, this was 8. Activity E, it was also 8. And activity B, the late start was 0. And then the late start for activity A was 1, right? So day 1. So therefore, our slack here is just going to be 1 day. So our slack on activity A was 1. Our slack on activity B was 0. Our slack on activity C was 11. Our slack on activity D was 1 day. Our slack on activity E, 0 days. And that's it. Right, so this is how we create our network diagram, and it's also how we calculate our forward pass, backward pass, and then are able to calculate our total float. Well, float in general, right? So when we find our critical path, I did tell you that one of the things we like to do in project management is we like to highlight it in a different color. So I'm going to go through now and I'm going to change these to a blue color so that it looks different. So anything with 0 slack gets a different color. And the minute the colors come in, you can see how that network changes. So we know that anything blue, we need to focus and absolutely not mess up there. So that is how we calculate uh, early start, early finish, and then we calculate our late finish, subtract the duration from that to find our late start, and then use that data for our floats.